All right, so a spectroscope. What is this? Well, you probably did this in elementary school and either you don't remember or you just didn't know exactly what you were doing. Right, you take a flashlight, or even maybe middle school, and you put it through a crystal, shone it through a little slit into a crystal, and it came out the other end as a lovely rainbow. And your teacher explained to you that white light has all of the different colors in it. That was a spectroscope. And we do these in astronomy. Okay? I'll show you how in just a minute. Alright, so we use this to find out emission lines. Okay, if you take a heated gas and you put it through a spectroscope, right, so instead of a light source, you actually have a heated gas that's glowing, and put it through the prism, and you'll separate the colors. Now, if you look there, you can see kind of a red, a green, a violet. Those are called emission lines. Those are the colors that that particular element is giving off. And it's kind of like a barcode where each element has its own emission lines. So here's some examples, just so you can see. You don't need to memorize these or anything. But hydrogen, sodium, helium, neon, and mercury. They all look different with the emission lines. So if you have a gas, you don't know what it is, you put it through the spectroscope, you get the emission lines, you can figure out what it is just by comparing it to all the other elements. All right, so here's the sun's light. You'd think it should be continuous, right? It's not. Almost continuous, but not completely. So it's got these little black lines. Those are called absorption lines. We'll talk about those next. All right, so absorption lines. Basically, this is the opposite of emission lines. And as you can see by the picture at the bottom there, the emission lines, you've got your reds, your blues, your greens. And then the absorption line has the black lines in it. And they're completely opposite. Why is this? Well, because instead of using a hot gas and putting it through a prism, we end up using a cold gas. Now, a cold gas doesn't emit as much light, so you need some sort of light source behind it. So if you look at the picture, you see the hot bulb, basically a light source, going through the cool glass and then going through the spectroscope. And you get absorption lines. Now, the absorption lines are also unique to each element, just like the emission lines, and they're exactly backwards from the emission lines. So Kirchhoff was actually smart enough to realize that these things are kind of related, and so we have Kirchhoff's law. Basically, if it's hot, it will give off emission lines. If it's cool, you need some kind of source behind it, and it'll give off absorption lines. That's basically what he said. So low-density hot gases emit light that has a spectrum of bright emission lines, and low-density cool gases will absorb wavelengths of light from a light source. So again, hot, it will give off lines, emission lines. Cool, it will absorb it, so it'll give off absorption lines.